Hello everyone. In this session, I'm going to explain about non-recursive predictive parsing or non-recursive predicting parsing, and also can be called as the predictive parser, can also be called as the recursive descent parser without backtracking, or we can call it as LL1 parser. So here, predictive parsing is a special form of recursive descent parsing. We can say it is a special form of a recursive descent parsing, and where here a backtracking does not allowed. Actually, backtracking is not required here. Why? Because whenever there is a possibility of replacing a non-terminal with its production, it checks which is suitable before replacing that non-terminal. How many productions are there? Suppose S derives AB and also S derives ABC. Suppose S derives AB and ASB. So before producing or before substituting in the place of S, AB or ASB, it chooses which matches with the input string, and it chooses any of one production for the elaboration of a construction of a parse tree, which is actually cannot be possible in the backtracking method. So without using the backtracking here, it chooses at the first attempt only which production can be replaced with its non-terminal, then we will get the desired input string. So that is the reason why here in this topic or in this method there is no requirement of the backtracking. So here we have why we can call it this non-recursive predictive parsing can also be LL1 parsing. Why? Because the parser follows the leftmost derivation. All these methods follows the leftmost derivation, and what the LL1 stands for here is nothing but the first L. The first L here is indicates the left to right scanning of the inputs. Whatever the inputs we are having in this method, it starts the scanning of the input, starts from the left and moving towards the end of the right. And the second L indicates the leftmost derivation procedure, and one within the brackets indicates only it moves one number of look ahead symbols. It moves only the one ahead symbols. That is the meaning of LL1 parsing. So this is the representation of non-recursive predicting parsing, or we can say a simple algorithm which follows the non-recursive predictive parsing, or we can say the recursive descent parsing without backtracking, or we can say the predictive parser, or we can say the LL1 parser. So it consists of a parsing algorithm, or we can say a parsing program, that is a predictive parsing program, one buffer, one stack, and the table and the output. So these all works together to get the desired output which is needed for the user. So first starts with the buffer. Here this we can call it as the buffer. The buffer is consist of the input string which a user has to be passed. The user has to be first, and here you can observe the end of the buffer is going to be ends with the dollar symbol. It's a dollar symbol, and this is the stack where push down contains the sequence of the grammar symbols. How many terminals or non-terminals are available in the grammar that are going to be pushed into the stack every time whenever that particular production is used for the parsing. So here the parsing table is going to be following the 2D array method, that is the M of A comma A. M of A comma A, where A stands for non-terminal and small a stands for the terminal. So this parsing table is going to be holding all the grammars or all the productions consisting in the grammar. And by using this algorithm, the output is going to be generated with the help of the buffer, stack, and the symbol table, parsing table. So let's see how this is going to be performed by following some rules and with an example. So here I have clearly given how many names we can use for this method. So I have given the heading as predictive parser, and it can also be called it as the recursive descent parser without backtracking, or we can call it as the non-recursive descent parser. So it is a top-down parser, and it is efficient way of implementing a recursive descent parser, that is nothing but without using the or without allowing the backtracking. And here it uses the stack, and the stack here, what is the necessity of stack is nothing but for recursive calls we are going to be using the stack. Whenever we need a production, every time we are going to be calling that non-terminal. For this recursive calls we need a stack. And the predictive parser can correctly guess, or it can also predict which production should be applied to get the input string without allowing the backtracking. By choosing whenever it needs to replace a non-terminal with its production, it chooses by guessing or by predicting which production may get the input string successful. By choosing like that, it is not going to be following any backtracking. So these are the steps. These four are the important steps, or we can call these four steps as the algorithm to be followed to apply the predictive parser method. So here we can say a few actions it should be followed for the parsing of the predictive parser. So suppose the first condition here is if x is equal to a is equal to $. Suppose we'll have the stack. The stack will be like this. The starting of the stack will consist of $, and this is the buffer. The end of the buffer consisting of $. Right? So check the first condition. If x is equal to a is equal to $. So if x is nothing but the stack, x is nothing but here a non-terminal. A non-terminal will be available in the stack, and a is nothing but here string which is available in the stack. So if both x is equal to a is equal to $, that is nothing but whatever available in the stack and whatever available in the buffer, both are equal to $. Nothing but stack is empty and input string is empty, then the values present in the stack is equal to values present in the buffer. That is nothing but, so whenever there is nothing in the stack and the buffer, now what is the value of stack? $. What is the value of the buffer? That is $. So now we can say x is equal to a is equal to $. If it is such case, then if the symbol on the top of the stack and the current input symbol is equal to $. So now we can say the top of the stack is now it is $, and the current symbol at the input symbol input buffer is $. So at the final, whenever the situation is like this, then it confirms the parsing is successful. It is one point you have to, or one rule you have to follow. Coming to the second condition, if x is equal to a but does not equal to the $, nothing but x is here is nothing but a value which is present in the stack. Suppose if stack is consisting of some a and the buffer is consisting of some a. So now x is nothing but the value present in the stack, and a is nothing but value present in the buffer. So now what is the value present in the top of the stack? That is a. And we are checking the value with the present in the input string, current position string. So what is the current position string in the buffer? A. So now a is equal to a but does not equal to $. When equal to $, if it is nothing in the stack and nothing in the buffer, then top of the stack and end of the buffer both are the $. So there is some value a is equal to a but does not equal to the $. In such cases, the symbol on the top of the stack is same as the correct input symbol. So the symbol on the top of the stack and the value in the current position of the stack both are a but not equal to the $. Then pop x from the stack and advance the input pointer to point the next. In such cases, what it is going to be doing? It is popped from the stack, and now the current position of the pointer is here. So it moves towards the next pointer. Look ahead antunam, look ahead, we are telling that look ahead, so that the pointer is moving from the current position to the next position. This is the second case. So whenever the values both present, the values present in the stack, top of the stack and current position of the buffer both are same but not equal to the dollar, then what action it has to do? It has to do the pop from the stack and the pointer should be moved 1 point towards the next position. This is the second rule. Coming to the third rule, if x is a terminal and not equal to a, that is, suppose here what we have in the stack. So in the stack we have some terminal B. Suppose, for example, I'll give you example for clear understanding. Just first understand about the points here. Suppose stack is consisting of B. Here x is nothing but a terminal. They said a terminal, so that I have taken the B, and which is not equal to A. So here it is consisting of A. The symbol on the top of stack is not equal to the current symbol A, then error. Why? Because this B is the terminal. We cannot replace or we cannot elaborate a terminal, so that if both are not equal, then this has to be reported as error. So this is the third case. And if x is non-terminal and a is input symbol, the parser consults the parsing table m of x comma a, which contains either as an x production or an error entry. So here again in the fourth point, two possibilities are there. What they are saying, if the stack, what the stack is consisting x, if x is a non-terminal, suppose a is there, A is a non-terminal. So now we are considering x is a non-terminal. Suppose x having the production as A. So if the stack, top of the stack consisting of A and the buffer, in the buffer the value is A, then what the parser is doing? Parser is consulting the parsing table and it is going to be finding out, that is x comma a. Here x is nothing but the non-terminal and a is nothing but the terminal which is produced by this non-terminal. So now what the parsing table will provide? A comma a. Why? Because a is deriving a. So in such cases, if it is like this, then this x can be replaced with its production. So a is producing a. So like this the parser is going to be doing. This is one case which contains either an x production or an error entry. When we can call it as error entry? If a is deriving some other BCD, or else if a is having no production. If a is here, but a in the grammar we have s derives some ab and b derives some sac, like this, but there is no production giving the in the grammar we have a non-terminal a at the RHS side, but actually a non-terminal does not having any production. In such cases it will be reported as the error entry. Suppose a is deriving some non-terminal or a terminal, whatever, a is having some production, then what it is going to be doing? So a derives some abc, like this we have the grammar. So then is the corresponding production. The parser pops x from the stack and pushes the UVW in reverse order on the stack. So now in such cases what it is going to be done? If a is having the production, if a is a non-terminal and a is having some production, then a will be popped from the stack and the production which is produced from that non-terminal will be replaced or will be pushed into the stack in a reverse manner. That is nothing but here a is producing ABC, but this will be pushed into the stack as CBA. Like this it is going to be pushed into the stack. Otherwise, if A is not having any production, the grammar consisting of only S and B, A is available at the RHS side but it does not producing any production, then it can be called it as the error entry, and further it cannot parser towards the next step. So to apply the predictive parser technique, these 4 steps has to be remembered, and by following these 4 steps, by applying the predictive parsing technique or LL1 parsing technique, we can check a given input string can be parsed successfully or error, or we can say the productions cannot be possible move towards further parsing. So I'll explain one example for the clear understanding. So we have one grammar here, E derives some, so for applying the top-down approach, the grammar should not consisting of any left recursion and left refactoring. So here, first of all, you have to check for that. So in this grammar, there is no left recursion and the left factoring. And here you can observe the input string. What we have to parse is ID plus ID plus ID into ID. So for this given grammar, by applying the predictive parsing method, we have to check whether this input string can be parsed successful or error. So initially the stack and the input string are empty. So the stack, the top of the stack will be dollar, and the input string will be, end of the input string will be also dollar. So now whenever we start applying, first we have to insert this string into the buffer. This string into the buffer, and this is the given predictive parsing table. This predictive parsing table should also be constructed by the user by applying some first and follow methods. For the construction of this predictive parsing table, I'll explain in the another session clearly. Now for parsing the given string, this table is not necessary. So that I am moving towards the next step. So these are the sequence of moves to find out whether the given input string can be accepted or error. So here we need 3 columns. First one is the stack, and the second one is the input, and the third one is what action we have performed. So here we are going to be using only 4 actions, that is the accept, error, push or pop. Only 4 actions are allowed here. So first, initially the stack starts with the dollar. Definitely you have to write the dollar, and here in the input you have to write the input string what we need to parse, and ends with the dollar. And here first we have to start with the initial state what we have in the grammar. Initial state what we have in the grammar, that we have to consider. So for understanding purpose, I will write the grammar here. What the given grammar? E derives E dash derives plus Te dash epsilon, and T derives Ft dash, and T dash derives into Ft dash epsilon, and F derives E or ID. This is the grammar, and the input string is ID plus ID into ID. It should be first placed in the input with the end of the dollar, and in the stack the dollar should be placed in the first position. So now always by default the stack will starts with the, by default the stack will be starts with the initial production. Here the initial production in the given grammar is E. So that first we are going to be checking with the E. So now you have to consider this is X, this is X. Now the pointer is at the starting of the input string. The pointer and the buffer, which is the buffer is holding the input string. So the current pointer, the current position of a pointer in the input in the buffer is starting of the string. So now the current position of the buffer is starting of the string. So now this is A and this is X. So what is the first rule we have? If X is equal to A is equal to dollar, then the parsing is successful. So now here it is A. Here it is E and here it is ID. So here X is not equal to A. Here X is not equal to A. So if it is not equal, what we have to do according to the step 4? That is step 4, we have the if X is a non-terminal, if X is a non-terminal, then go to the parsing table and you have to find out the X production, so that we are going to be parsing table and we are getting what E is actually deriving, TE dash. So E is having some production, so it is not an error. So we are getting the action, that is E derives TE dash. Now this production is going to be pushed into the stack in a reverse order. So E will be popped from the stack, and now in the stack the E production will be pushed in the reverse order. So reverse order is nothing but first E dash will be pushed, then T will be pushed, and the input string is same as it is, and again the position is at the same position. Now again checking the top of the stack is T. So now T is not equal to ID. So again step 4 we have to repeat, that is we have to check whether T is having any production in the grammar or not. Yes, T is having some production. So that what is the production? T derives FT dash. So T will be popped from the stack and E dash will be same in the stack. In the stack E dash will be as it is, only T will be popped. In the place of T, the production of T will be pushed in the reverse manner. So what is the production of T? FT dash. So T dash is first pushed, then F is pushed. Now top of the stack is F. So F is not equal to ID. The position of the input string will be in the same position until it matches with the X, or if in the X, if it is a non-terminal and it does not having any production rule, then it reports the error until unless the position of the input string pointer will not be changes. So now the top of the stack is F and the input string is ID, which is not equal. So again we are going to be checking F is having any production. Yes, F is having some production. So F is having the 2 production, that is this one, first one and the second one. So here no backtracking is allowed in the predictive parser. So it chooses the by predicting which will get the parsing successful. So whenever it is going to be checking with these two, it can identify ID can be successful by taking the ID in the place of S, in the place of F, it can parse successful. So it chooses F derives ID. So now F will be popped from the stack. E dash and T will be as it is in the stack. And in the place of F, its production ID is there, only one non-terminal, so that it is pushed into the stack. Now ID equal to ID. So we are going to be moving the second rule, that is X is equal to A. But does not equal to dollar. So X is equal to A is nothing but here X is ID and A is ID. So both values are same, but both does not equal to dollar. So then we can pop this ID from the stack and the pointer can be moved forward into the next position, look ahead position, moving one step forward in the input string, so that we are going to be popping ID from the stack and removing ID from the input string and writing. So that the action here, what action we have done here? Removing ID. The action we performed here is removing ID. So in the stack, Now after pop id, we have the e dash and t dash as it is, and writing the remaining string as it is, plus id into id dollar. Now the position of the pointer is at plus. Now it is going to be checking t dash equal to plus. It is not equal to plus, so that we are going to be checking the production for t dash. T dash is having some production. So t dash is having some production, that is into f t dash. If we take this production, the input string is having plus. If it replace it, first we are going to be getting into, which is not matching with the input string, so that it chooses the second production, that is the epsilon. So t dash derives epsilon. Epsilon is nothing but null, no value. So we are going to be popping t dash, popped t dash from the stack, and we can write epsilon. Epsilon is null, so that we are not writing any value here, and writing the same input string as it is, so the input pointer is at plus. Now we are checking e dash plus, not equal, so writing the production for the e dash. So popping the e dash from the stack, writing the e dash plus t into the stack, e dash t plus into the stack. Now plus plus both are equal. Both are equal is nothing but we can remove plus. We can remove plus both from the stack and the input buffer. What remaining input string is here? id into id dollar. So plus is removed from the stack, so that remaining with e dash t. Now checking the position is at the pointer is at next position of the input buffer. So now it is at the id. So checking with t with id, both are not equal. So taking the production of t, so it consists t derives f t dash. So t is popped from the stack, t is popped from the stack, and writing its production in reverse order into the stack. Again checking f id, not equal, considering the f production, and this f is popped in the place of f, its production is written. Now id and id both are equal, so removing id and remaining, and we are left over with into id dollar carried to the next step. So now the position is at into, and checking t dash with into, not equal. Now we are checking t dash production. We need to parse into, so that first production is going to be considering into f t dash. This will be pushed into the stack in a reverse manner. T dash will be popped and its production will be replaced in the reverse order. So into and into. So into and into both are matching, so that we are removing into from both places, that is stack and the input buffer. Now f is there. And remaining whatever the top of the stack is f, the position will be moved into the id. F is not equal to id, so again in the place of f, id will be taken. So f will be popped from the stack. In the place of f, its production is replaced. So now checking id both are equal, so id will be removed. Now we have t dash, e dash, t dash. So in the input string, no non-terminals are available, no string is available to compare. So t dash is having the epsilon, so that we are replacing epsilon, and e dash is also having epsilon, so that we have taken epsilon. Now e is there, and E is there, and it is the dollar symbol. So E is nothing but the starting symbol. We have started with the starting symbol and again reached with the starting symbol. So now by this we can understand that the parsing is successful or the parsing is accept. So like this we have to perform the predictive parsing by considering the 4 important steps given in the algorithm. By following these actions, by replacing its productions and non-terminal with its productions, we can able to parse the given string. Either it can be parsed successful or getting the error. So whenever input string is accepted, it is nothing but the parsing is successful. Thank you.